Hello, everybody, again. We are starting with our next session. Now with me is Mete Atamel, and Mete will tell us about choreography versus orchestrations in serverless microservices. So, hello, Mete, nice to meet you.
Nice to meet you too.
Yeah, so let me start with kind of maybe complaining or something like that to make the opening chat. So I have a feeling that nowadays we are trying to get back somehow to monoliths application, especially modular monoliths application, due to the fact that microservices giving us a lot of nice things like modularizations and so on, but there's a
Yes.
big overwhelm with additional things like connections, networking, all of that stuff. And most of applications, to be honest, does not need such kind of overhead during the development, during the use. But there are some applications which, of course, has to be built in that microservices approach. So my question is, choreography versus orchestration, is there any straightforward answer for that, or not?
Well, there's never a straightforward answer in software engineering. It's always, well, the standard answer is it depends. It
Yeah.
depends what you're trying to do. And I think that applies here as well. And actually, I will talk about this in my presentation, like what it depends on.
Yeah, okay, so great to hear that. So the floor is yours, and having fun.
Okay, thanks very much. So let me share my screen before I forget. Um,
Yeah, we can see that now, at least I can.
um, so you see my world screen, right? Is that right? Or no?
No, I can see the presentation.
So 1 second. I need to share my whole screen. Yeah,
Okay.
there we go. Now you should see my world,
Yeah, exactly.
and then now you should see my presentation, right?
Yeah, exactly.
Okay, great. So hello everyone. My name is Mete Atamel. I am a developer advocate at Google, and today I'm going to be talking about choreography versus orchestration. As you see in my slides, I put the serverless micro in parentheses, and the reason for that is that the concepts that I'm going to talk about, it actually applies to all services. They don't have to be microservices. They can be macro services if you like. And they don't even have to be serverless. They can be just plain old services running on a virtual machine or something like that. So the talk is about how do you organize your services? How do you kind of make them communicate? That's the essence of the talk. And it's a bigger problem in microservices because in microservices, you have more services and then you have more problems. One of them being how do you organize them. So that's why the context is probably more for serverless microservices, but it doesn't have to be. So even if you have your plain old monolithic kind of services, you still need to think about these issues. So that's why I have it in parentheses. The presentation is already on speaker deck, and if I have time, I'll show you some demos. They're already on GitHub, so I'll share all the links at the end of the presentation. And if you have any questions, please ask in the chat, and I'll try to save 5 minutes in the end to answer those questions. Okay? All right, so first of all, what do I mean by choreography and orchestration? So let's go through this question with a scenario. And imagine you are building an e-commerce application. In an e-commerce application, you have an e-commerce transaction, and in transaction, usually there's an order of things that should happen. Usually, the user has to order something, and then there's a certain steps that needs to happen. Now, if you need to design this kind of a system, of course, one way of doing this is to have a monolithic application that does everything. You could do that if you like, but that has pros and cons. But nowadays, what we try to do is basically small services that do one part of the transaction. So one way of doing this on Google Cloud would be, maybe you have a front end, which is usually an app engine service that receives the order. Then you have a payment processor, which is a cloud run service that runs a container to do the payment processing. Then maybe you have a shipper that does the shipping related tasks of the transaction, and this might be a cloud function, so it's just a function that does that work. And then finally, you want to notify the users, so maybe there's a notifier cloud run service that sends a notification using SendGrid or something like that, right? So you have these microservices doing their part, and then you can combine them together into a transaction by just making them call each other. So you have the front end calling the payment processor and payment processor calling the shipper, right? So this could be an easy way of doing this. Of course, I'm simplifying this immensely here. In a real world e-commerce application, there's many more steps, but just bear with me. Now, in this simple REST-based approach, there is pros and cons. The pros is that it's better than a single monolithic application, probably, right? You could do this in a single service, but I don't know, like it feels like smaller microservices that are doing their own parts is probably a better way to go for many reasons. Secondly, this approach of services calling each other, it's very easy to implement and it's very easy to reason about. You don't need to think too much about it. So it's simple architecture, and simple is usually good. So it's good in that sense. Now, on the other hand, you are already having too much coupling between your services. And you know what I mean by that is that, if you want to change one of the services in the middle, then you need to think about what that service calls and who calls that service, right? So you can't just change that service and forget about the rest. You need to think about these dependencies of this service. Each service can be a single point of failure. So if the payment processor doesn't work, then the whole transaction doesn't work really. And when some service doesn't work, you probably want to do some kind of error or retry logic. So you need to apply that somewhere, usually within your code somewhere. And for me, the biggest problem is that there's nothing ensuring that the whole transaction is successful, right? So if some of the services fail or if they don't do the right thing, how do you know, or what do you do, right? And there's actually a pattern called Saga pattern that I'll talk about later that helps with this kind of stuff. So the point of this simple REST-based approach is that it's easy to reason about, but at the same time, it's not so great because it has its own issues. So what you can do is that instead of doing this simple REST-based approach, you can do what's called choreography, or also known as event-driven. And in this approach, you still have your services deployed independently as microservices, but instead of communicating directly, they use a message broker or message bus, whatever you want to call it, and they just pass messages around. So the front end will receive the request, and it will just emit a message saying, I received an order. And then the payment processor will pick that message because it's the one interested in that kind of messages, and it will do its part. It will do the payment processing, and then it will say, I process the payment, and so on and so forth. Now, what is the good thing about this? Well, again, there's pros and cons. The pros is that your services are loosely coupled, much more than before. Because if you need to change a service, you don't need to really worry about the other services anymore, because everything happens through messages. So because of that, like, you don't really need to care about the dependencies so much. You still need to care about them a little bit, especially if you change the message format, but it's not like a direct call from another service that you need to worry about. Services can be changed and scaled independently much more than before. You don't have a single point of failure in the sense that if a service doesn't work, it will just not process certain messages, and those messages will probably back up. But the rest of the services, they will continue to work. Now, this doesn't mean that the transaction will be successful, but at least your system is kind of working, like half working in a way. This might work in some use cases. And events are very useful to extend your system. So if you need to add a new service, all you need to worry about is just deploy the service and configure what kind of messages that service is interested in. You don't need to change anything with your existing services. Now, of course, there's some cons in this approach. First, now you have all these events flying around, and it becomes kind of difficult to monitor what's happening in your system. So let's say you receive an order, but the order doesn't work, like the transaction doesn't work, then it's not so obvious what failed. You have to kind of track the events, and kind of figure out from the event correlation IDs and logs and where things kind of broke. But it's not as straightforward as before. The errors and read writes and timeouts, you still need to do them. So if a service doesn't process a message, you still need to think about what to do. And you kind of lose the business flow of your application. So if you have a flow in your application that you can visualize or put it in a flow chart, you kind of lose that in event driven, because in event driven, you don't have that flow anymore. You just services just some just just sending messages and receiving messages. So that kind of information is kind of lost and it's not captured anywhere. And this problem of who ensures that the whole transaction is successful is still a problem. You need to kind of worry about that and think about that when you're designing your system. And if you look at a more complex transaction like this one here, trying to take this transaction and trying to make it event driven is possible, but it will be difficult, right? So now when you look at this flowchart, for example, you see that you start your transaction where you check a database, then you do an if something is in stock or out stock check, and then maybe you call a third-party API, and then you use SendGrid to send an email. So when you look at this, even though it's more complicated, it is easy to understand, and there's a straight flow that happens, right? Now, when you take this and break it into services that do their own thing, and then you need to do the third-party API calls, and you need to call SendGrid, stuff like that, then all of a sudden you lose this flow chart. And that's a shame, because this flowchart has a lot of value that we want to actually capture. All right, so what can you do then? Another approach is what's called orchestration. So in orchestration, you have this external service called orchestrator. And in this orchestrator, you define what should happen in your architecture. So how should the calls happen? So you encode that somehow, and I'll talk about how you encode that. And once you do that, you might be receiving the orders again from the front end, just like before. Then the front end calls the orchestrator and says, okay, I received a new order. That kicks off an orchestration. Then the orchestrator will look at its rules and it will say, okay, I'll call the payment processor with these values, get the result back, and I'll call the shipper, get the result back, and I'll call the notifier, get the result back, and so on and so forth. Now, in this approach, again, there's pros and cons because nothing is perfect, so it's always a compromise. The pros is that now you have a central place to capture the business flow, the flow chart that we have. And since you can capture it, you can encode it, you can version it, and if someone comes along and says, how should my system work, there's a place you can go and say, okay, this is how it's supposed to work, right? So this has a lot of value for monitoring, and it has a lot of value even for business reasons, that if someone wants to just learn how the system works, there's a place to go and look at that. In orchestration, there's this notion of steps. So things happen in steps, and each step can be monitored. If something fails, you know exactly where it failed. It failed in this step, and you can just zoom in there. So you don't have to worry about where things fail. It becomes really obvious where things fail. The errors and read writes and timeouts, you still need to do them, but you can centralize them now. You can apply those policies in the orchestrator, and that helps you a lot because you don't have to do them in every single service. And your services are still independent, right? They're still independently deployed, and they can be scaled independently, but you kind of bring them together into what I call a temporary monolithic orchestration, right? So they are independent, so you get the benefits of independence, but you kind of bring them together into orchestration. So you also get the benefits of kind of monolithic kind of applications, but it's not monolithic. It's just brought together by orchestration. Now, on the other hand, your orchestration service is it's a new thing that you need to learn and maintain. It can be a single point of failure, because if the orchestrator doesn't work, then there's going to be no calls. So you need to make sure that you're using an orchestrator that's resilient and redundant and all that kind of things. You lose a little bit of eventing flexibility. So now if you need to introduce a new service, you need to deploy the service, but you also need to change the orchestrator and use that service. So orchestrator has to be changed and deployed as well. So it's not as flexible as eventing, basically, in that sense. Now, as I mentioned, in orchestration, it's easier to spot the problems, but once you spot the problems, you still need to take care of them, right? So if a step fails, you need to think about what to do. Like, do you retry? Do you ignore? Or do you need to take a compensation step? So those problems are still there. They're easier to manage, I would say, but they're there and you need to think about them. And again, this saga pattern helps here, and I'll show you an example of this later. So you might be having a question right now, which one is better, choreography or orchestration? And as I said before, it depends. But there's usually a couple of guidelines I use to kind of decide which one to use. Usually I start thinking about choreography when my services are not close to related. If my services, they're quite independent, they do their own thing, they don't really need to call each other in a certain order, then that's when I'm starting to think about an event-driven kind of architecture. Also, at the same time, if my services can exist in different contexts, like let's say I have a notification service, and this notification service can be part of some other transaction, then it makes sense to include the notification service as an event-driven service where an event just triggers it, right? Because it can live in different places, and by having it event-driven, I can plug it in easier to different places. On the other hand, if my services are closely related, they're usually deployed together, they usually call each other in a certain order, then I want to maintain that order. And that's when I start thinking orchestration. Also, if I have this flowchart that I showed you before, and I want to kind of maintain that flowchart, I want to version it, I want to change it, I want a place to kind of capture that, then that's when orchestration becomes useful. You can also combine the two, right? And I think this is what I usually see in the real world, is that you orchestrate things that make sense, but then that orchestration can be triggered by an event, or maybe at the end of the orchestration, the orchestration can signal other orchestrations using an event as well. So this hybrid approach is also very, very valid, and that's what I see most people do nowadays. All right, so that was a really quick introduction to choreography and orchestration, pros and cons, and all that kind of stuff. Now I want to talk quickly about what kind of tools and services exist in this area. So when we look at choreography, like event-driven, there's a lot of choice. I'm not going to go through all the names here, but no matter where you are, like which cloud you're running on, there's a lot of choice. So don't basically write your own service. There's services already out there. And then on open source, there's Kafka, there's RabbitMQ, there's other things like Serverless and things. So there's a lot of choice basically when it comes to event-driven architectures that you can use. And this is not a full list, it's just the first few that comes to my mind. In orchestration, since it's a newer kind of concept, there's less choice, but there's still choice. So on AWS, there's step functions. On Azure, there's logic apps. Google Cloud, there's workflows for service orchestration, Cloud Composer for data orchestration. And there's open source solutions like Airflow, Camel, Camunda. They are more in Camel and Camunda. They are more in like a business orchestration. So orchestration is kind of an overloaded term. There's like service orchestration, data orchestration, business orchestration. So depending on what you want to do, there's different orchestrators as well. And there's also, oh, by the way, I did a little bit of comparison between step functions, logic apps, and workflows. And as you can see from this table, they pretty much provide the same kind of building blocks. Whereas if you look at more advanced features, the logic apps seems to have the most features, followed by workflows, and step functions seems to be more geared towards AWS ecosystem, but not so much for things outside AWS. But more or less, they give you what you need for a basic kind of orchestrator. And there's also an open source project from CNCF called CNCF Serverless Workflow that tries to define a specification for defining workflows, SDKs to SDKs for different languages to define and run workflows. There's runtimes and there's tooling around it. I haven't looked into it in too much detail, but it's something that's coming up, and they're kind of trying to create a standard basically out of this workflow kind of outside this workflow services. Like how do you do this like orchestration with services in an open source kind of way? Unfortunately, none of the cloud providers they support this open source definition specification yet, but it's something to look into, and maybe at some point there will have services in cloud services that will support this specification, because it would be really cool to define a workflow in a common format and deploy it in different places, because they're all kind of trying to do the same thing, and nowadays you need to kind of learn each way and deploy it in differently, but it would be good to have a standard, and I think this might become one. All right, so that's the landscape, and now let's zoom into Google Cloud Workflows, which is Google's own service orchestrator, and I want to show you some quick features of what this workflow service is, just to give you an idea on what you can expect from an orchestrator and how it helps you. So it will kind of make it more concrete when we look into this. So workflows, it's a service from Google Cloud that lets you basically orchestrate and integrate different services. The cool thing about it is that it lets you orchestrate your code. So if your code is running on Cloud Functions or Cloud Run or basically anywhere on Google Cloud, you can include that code in your orchestration. Not only that, but you can also include any Google APIs, any Google Cloud APIs in your orchestration. And you can also include external APIs. So if you want to call a service externally, as long as you can access that service from Google Cloud, you can include that in your orchestration. And I like this because, in your applications, usually it's not just about your code. It's about your code calling some APIs, whether they are part of the cloud API or external API. It's usually a combination of all of that. So workflows allows you to kind of combine all of that into one orchestration. And I have some more slides to go through, but maybe I can show you this example from GitHub just to give you a flavor of how it works. So I have this example, and all of this is on GitHub open source. I'll share the links at the end of the presentation. But basically, let's say you have a few services that are running in different places, and you want to chain them together, just like I showed you in the previous example. You want to just, you want this service A called service B called service C, so on and so forth. So how can you do that chain with workflows? Let's take a quick look at that. And in this service chaining, I have a function, cloud function called random number. It's a Python function that just generates a random number, so something very simple. Then I have another function called multiply. Again, another Python function that given two numbers, it just multiplies those numbers. Again, it's something very simple. Then let's say we have an external function from math.js, and we want to use that to take the log of a number. So in math.js, you can take the log of a number like this by passing an expression. So let's say we want to call this as like the third step. And then as the fourth step, let's say we have a Cloud Run service, which is a container service that takes the floor of a function, right? So you pass in an input like this, and it will return you 6. Basically, it takes the floor of the function. So as you can see here, we have 4 functions, 2 cloud functions on Google Cloud, 1 external function from math.js, 1 Cloud Run, which is a container service, and we want to kind of put those together. And how we do that is that we define a workflow.yaml, and this can be also a JSON, by the way. So this is how you define your orchestration, and then you define steps in this orchestration. So first step, and you can call these steps whatever you want, but here I call it random gen function, and I define what happens in this step. So here I'm making an HTTP GET call to this Cloud Functions URL, and then workflows will make this call for me, and it will capture the result in random gen result. So that's where it will capture the result. Then in the next step, I call multiply function, and then this time HTTP post, and the body of the HTTP post will have the result from the previous step. So we look at the random gen result from the previous step, look at the body, and get the random that includes the result from the previous step, and pass that in, right? So that's how we'll do the multiplication, and I think we'll just multiply it twice or something like that. Then the third one is a log function. This time we are making a get call to math.js, so making an external call, and we passing in the query expression because it expects the question mark query expression, and I just call the log function with the result from the previous step as well, and capture the result in the log result. And finally, in the last part, I call the floor function. This time I'm calling a Cloud Run service, and it's a private service that expects some authentication. So I'm passing this authentication type so that I can call it from workflow. So even though it's a private service, I can still call it. And I pass in the input from the previous step again, and I capture the result. And in the end of the workflows is that we just return the result from the last step. So floor result will be our return. So this is how you define it, and then you can deploy from console if you like. So I already deployed here. So let's just take a look. So let me say service chaining. Yeah, I already deployed it here. And then if I look at the source, you can see my source that I show you. But the nice thing is that I also see a visualization here. So I can see that it's a chain of functions, which is really nice. So I'm capturing my business flow, even though this business flow is very simple, but this gives you an idea the kind of things you can do. And if I want to execute, I can just execute it from here. There's an input, there's going to be an output, but in this case, there's no input. So I'll just hit execute. And now this will run the chain. The execution is running, and within a few seconds, it will run and give us a result. So when it's finished, we'll see that there's no input, but the output is 5, and with some HTTP headers and code as well. But this is my result basically that I returned. And if you check the logs as well, we'll see that the whole chain was executed as well. So this gives you an idea of how to define workflows. So let me see what slides I can skip now. So this is how you define it. We already talked about this. The only thing that I would add here is that you can do this definition in YAML, but it can also be in JSON. So if you have a preference, you can choose JSON as well. You had the idea of steps and JSON parsing that we talked about. I didn't show you, but you can apply errors and retries around these steps. So that if you want to, for example, say, I want to apply 5 retries in an exponential backoff policy, you can do that around the steps. And that policy is applied to either individual steps or all steps as well. Or if if one of your steps fail, you can send that result to another step, or if it's successful, then you can send that result to the next step. So you can do this conditional kind of branching. Yeah, that's what I mean. Conditions and third-party calls that you can do very easily. You can create sub workflows so that you can use them for multiple orchestrations. There's connectors to connect to Google Cloud APIs, and there you can do iterations. You can do callbacks where a step can wait for a human to call back. So there's a lot of useful features here that I'm not really showing you, but I just want to mention so that you know that they exist. And to deploy a workflow, I show you how to do it from the UI, but you can do it from command line. So you first deploy your workflow, then you execute it, and then you see the execution by describing it. And then UI we saw as well. Okay, so hopefully, again, I know it's quick because I don't have that much time, but hopefully that gives you an idea how you can compose an orchestration in an orchestrator like workflows. Now, in the last part, in the last 10 minutes or so that I have, I want to talk about some patterns that I see in orchestration that helps. And through these patterns, we'll also see why orchestration is actually quite useful. Now, one of the patterns that I see is combining orchestration with choreography. Because sometimes you need the tight coupling of orchestration for some services. But at the same time, that orchestration doesn't have to be triggered in a tight coupled way. It can be triggered in a loosely coupled way. Or if that orchestration is finished, it doesn't have to call another orchestration, or it doesn't have to call another service in a tightly coupled way. It can actually just send an event. So I see this pattern a lot where you orchestrate things together, but you have an event that triggers it. For example, in this example that I have on GitHub, I want to create an image processing pipeline where a user saves an image to an input bucket, and then I have a number of functions that will process that image, right? So this first function is a filter function that will filter bad images using machine learning. Then I have a labeler function that will take the filtered images and it will extract the labels out of that image using machine learning again. Then there's this resizer function that will take the image and resize to a size that we define. And then finally, we have the watermarker that takes the labels from before and the resized image from before and creates a new image that has the labels on top of that image watermark, right? And saves it to the output bucket. So as you can see in this sample, um, these functions, they need to be deployed in an order, in a certain order, and they need to be called in a certain order. So first filter has to be called, then after the labeler and resizer, then after that the watermarker can work on the labels and the resized image, right? So because of that, it doesn't really make sense to make them event-driven, loosely coupled kind of way. They don't need to be loosely coupled. They need to be actually tightly coupled, and they need to be called in a certain order. So that's why it makes perfect sense to create an orchestration here. But then how do you call this orchestration? Well, that can be loosely coupled. When the user uploads an image, that can trigger an event that can go to the orchestration. And for that, we use something called Event Arc. It's an eventing service from Google Cloud that will look at the cloud storage bucket and it will detect that an image was saved and it will direct that to workflows. So you can look at this example on GitHub. And I will, I don't think I have time, so I'll just won't get into details, but feel free to check it out on your own time. Now, the second one I want to talk about is the retries and saga pattern. So what happens when things don't work? That's when retries and saga pattern come into play. And actually in this one, let me show you the example. So here, let's imagine we have an order service where we create a pending order. Then that goes to a customer service where we try to reserve credit. So we are trying to make sure that the user, the customer has enough credit to actually execute the order. And then once that's done, we call the order service again and we approve the order, right? So pending order, reserve credit, and approve order. If you want to do this, and if everything works, then it's very easy to do. You just chain them together in an orchestration and everything works. And actually, I show how to do that in ordering V1. If you look at this orchestration, we create 3 steps: create pending order, reserve credit, and approve pending order, and everything just works great. But the problem arises when the customer service, let's say, is not stable. It's flaky. Sometimes it works, sometimes it doesn't work. What can you do? Well, one thing that you can do is you can, instead of calling once, instead of making this call once, you can do multiple calls. So you can do retries between these calls, right? So that way, if customer service didn't really work the first time, maybe it will work on the second time or the third time, right? So this is a simple retry, and it's very easy to do in orchestration in workflows. So in version 2, I show you how to apply retries. So what we do is that we create the pending order like before, but then in reserve credit, now we have this try and retry block. So we make the call to customer service to reserve the credit, but if it fails with some HTTP codes that we define, then we do a retry. So this retry basically says, I want to apply this retry policy, default retry policy, which basically says if HTTP returns 503, service unavailable, or 429, 503, and so on and so forth. So if it returns any of these, then we'll retry 5 times. So that's the default policy that you get. So that's what I'm using here, the default policy. But this policy, the default retry policy, is it's just the default. You can create your own policy and you can apply that as well. So you can see how easy it is to apply a retry. You basically just try and retry, which is very useful. Now that helps us with the transient issues in customer service. But what if we have a permanent issue? What if we come to the customer service, we try to reserve credit, but we cannot because the user actually doesn't have credit, right? Now, what do you do in that case? Well, that's when this saga pattern comes into play. In saga pattern, you basically have this idea that I will try to do something. If it's successful, then we'll do the usual order, so the usual path. In this case, it's just approving the order. But if it doesn't work, if it fails, then we're gonna do the compensation step. So in this case, the compensation step is to reject the order. So here we create the pending order, but here if we cannot reserve the credit, we'll reject the order, right? So we were applying the saga here, taking a compensation step. So to do this in orchestration, let's look at the third one. Again, we create the pending order, we reserve the credit, and we apply the retry policy again. So if there's a transient issue, we are still doing that retry policy. But if there is something else, then we have this except clause. And in here, we checked what the error was. And if the error was HTTP 500, which is an internal server error, we conclude that this is an error that we cannot recover from. And we just go to next step called reject pending order. And this reject pending order will call the order service and it will just reject order basically. So that's the compensation step. Otherwise, we raise the error because it's an error that we didn't know about, so it will just stop the orchestration. And otherwise, if we don't get in here, we'll just approve the order and return the order, right? So that's the happy path. So that's how we can do read, write, and saga pattern in workflows, and I'm sure it's pretty similar in other orchestrators. Another pattern I see is parallel steps. So when I talk about orchestration, people see steps and say, okay, these are sequential, but what if I have a lot of things to do? Can I do the things in parallel? And the answer is yes. So I have this sample. I won't go into details because I don't have time, but in this sample, I show how to do sentiment analysis on different Twitter handles. But one thing I want to point out in this workflow is that I have this step where there's a parallel step and then a for loop. So this for loop loops over Twitter handles. So I'm looking at like multiple Twitter handles. And because I have this parallel keyword, they will happen in parallel. So if I have 5 Twitter handles, workflows will process them, all those 5, in 5 different branches, basically. So they will all run at the same time, and then we will combine the results in the end. And in the end, I mean, this is a long kind of workflow, but in the end, we'll return all the results from all parallel branches. So the point here is that when you can parallelize because it helps with the time of your orchestration. And I think this is the last one. Yeah, the last one I want to point out is that so far I talked about all serverless services. So the services were serverless, the orchestrators were serverless, which is nice. I like serverless because I don't have to worry about service. But sometimes you actually need service. There's limits to what you can do on serverless. There's, for example, a cloud function can have a certain amount of memory and CPU, and it can only run for up to 10 minutes or 15 minutes. Cloud Run can run up to 1 hour. So if you want to do a long-running task on a big kind of CPU memory kind of situation, you need a virtual machine, right? In that case, what I've seen work really well is combine servers with serverless orchestration. So what you can do is that you can have workflows, create a virtual machine the way you want, with all the extra resources that you want, and then run the workload on that machine. And then once the workload is done, get the result, and then delete the VM and return the result, right? So you can have an orchestration like that. And the cool thing about this is that you are using service, so you are not limited by serverless, but at the same time, that server management is abstracted away because of your orchestration. And in the end, you just execute your orchestration and get the result. So from the end user perspective, you don't care that there's a server behind the scene, but from an implementation perspective, you actually have the power of service as well. And I have an example of how to do this at this link, so feel free to check it out. So I'm almost out of time. What I want to tell you that in the slides, I have this case study where we show you a photo sharing application where we designed it using event-driven approach, but then we rewrote it using orchestration, and we are very happy with the results because it was much easier to debug, less code, less setup, easier handling. But then we also had to deal with some issues like new service to maintain, code versus YAML, debugging, testing, so on and so forth. But I won't get into it. If you want to look into more, check the slides, and I have some notes there that might help you. So yeah, thanks very much for listening. I just want to, before I answer some questions, I want to share the link. So this is the link for workflows. This is the link for the app that I talked about. And this is the workflows demos where I show you all the demos that you can get. And yeah, so I'll just pause here and see if anyone has any questions.
Yeah, we have some questions on our
Okay.
Q&A chat. So let's start with the first one. Shouldn't microkernel be more preferable over microservices when you need more of error handling and control while have advantages of extendability?
So shouldn't microkernel, they said.
Yeah, yeah.
Well, I'm actually not sure about microkernels. I haven't used them, so I don't know basically what the advantages are compared to microservices. So unfortunately, I don't know the answer to that.
Okay, okay. Also, I have one question from my side. So, what about, let's say, monitoring of that, even both orchestrator and choreographic versions? So, if we wanna, debug what caused some problems, why that service doesn't work properly, and so on and so on. So, maybe let's address that in that way. Monitoring for that kind of approaches. What can you tell us in that area?
Yeah. So if you look at event-driven services and monitoring them, it is kind of difficult because in event-driven, the way I think about it is that you have these services like not in a certain order, and there's an event bus in the middle, and they're just sending messages and receiving messages. So if something doesn't work, it's not immediately obvious like what failed.
Mhm.
So the way I kind of look into it is that I usually somehow know that things don't work because maybe a user tried to do something and they couldn't do it, and then from then on I try to kind of correlate them. So if there's a request ID, for example, that generates some message, then you want to carry that ID through the messages somehow. So you need to have this correlation ID messages, and then kind of trace that,
Mhm.
and then see where that tracing kind of broke, and then look into those services. And then at that point, I would get into the logs of those services and try to see if the logs tell me something. And usually I find that in some of the logs there's an error, and then I find it. But it's not straightforward. Like you have to have the correlation IDs, you have to have the logs and all that kind of stuff. In orchestration, it's easier because I show you there's steps in orchestration,
Mhm.
and these steps, like when something fails, you basically see which step failed, right? And that immediately narrows down from say like 20 steps to one step. So you just look into that step, and then if it's in the that's if that step is within the orchestration, then you look into your orchestration. Maybe there's something wrong in your orchestration. There's some logic error in your orchestration. But if it's referring to an external service, or if it's referring to another code that you have running on Cloud Functions, then that hints you that there's something wrong in that function, and you go and start looking into that function and logs of that function and figure out that way. So that's kind of my process on how I kind of try to monitor things and debug them further.
Yeah, but basically we can sum up that, from my opinion, that is that orchestrations are easier to debug, to investigate what's going on there. Yeah, rather than choreography.
Yeah, definitely. I think that's one of the biggest advantages of orchestration versus eventing is that they're easier to trace, easier to debug when something goes wrong.
Yeah, exactly. And last question from the chat: what is the tool that you use for that cursor per need for presenting?
Oh, for the cursor, yes, it's actually I'm using Google Slides, and in Google Slides, if you do, I think if you press L, then it gives you this thing. So it's basically part of Google Slides, nothing special.
Okay. So thank you, Mete, for your great session. It was pleasure to hear that and to see that comparison between orchestration and choreography. And I would like to invite everybody for the next session. So see you there.
Cool. Thanks very much for having me. Have a good rest of the conference.